So the next step in my 386DX build is to get this chip working. This is a versatile interface adapter. And from the last video, all I've done is I've just simply inserted that chip into this socket. And on my screen, you can see I've got the data sheet pulled up. This is for a Western Design Center W65C22N. Basically, this versatile interface adapter. And they describe it as a flexible I/O device, really for the 6502s, 65816 type of processors. And that's where I've used it in the past, and then I've used it also on my 286. I kind of like this chip, and I'm going to continue to use it. The main couple of purposes I intend to use this for. One is this will control all my SPI communication, and it will also help me do a system timer on the board. And so those are the main two uses I have for it at this time. Now, instead of using this specific chip, I could use a PPI, a programmable peripheral interface, and that might be more common on an Intel build. But for now, at least, I'm going to keep working with this VIA. So that's my plan. Now, if I go through the data sheet here, I can get down to maybe showing the pin out on this. And here's the pin out, and basically what you're going to see is that there's basically power and ground that you get applied, and there are two ports, two 8-bit ports that I can use. So I've got 16 I/O pins essentially that I can use, and I'm going to use those, like I said, for this SPI type of communication. Now, to control this chip, I can come over here and I have 4 signals that I can set, essentially tie it into an address is what I'm going to end up doing, an I/O address that lets me access 16 different registers to control how this chip behaves. And then there's things like a reset signal. There's an 8-bit data input output. So if I pick a register, I can write a new configuration, for example, to that register, or pull back. Maybe some of them I can read back information. I'll need to feed it a clock. And there's a pair of chip selects. One is an active high, one is an active low. Both need to be active for the chip to be active. There's whether I'm reading or writing. There's also a line that says I have an interrupt that's occurred. I need to raise that out to something. And a couple other signals here, but that's the basics of this. And if I go over here to my schematic, I have a portion down here that I have this specific chip. And so when I look at this here, what you're going to see is I'm connecting addresses 2, 3, 4, and 5. And that's going to let me control these signals. And then I've got my reset. I've got my data lines I'm going to connect in, clock. I'm just going to pull this chip select high. This chip select is an active low, and I'm going to drive that off of one of my PSOCs. So I have a PSOC here for address decode, and that's the one I'm going to try to manage this signal with. And then this read-write is going to come from this signal coming really from the processor. Now, if I want to take a look at how am I going to get this VIA signal, this chip select enabled, that again is coming off of one of my PSOCs. So way up here I have this decode PSOC. And in this decode PSOC is where I'm going to come out with this VIA signal. And I can jump over to my PSOC code, and this is what I have for my PSOC. And as you take a look at this, what you're seeing really is just what I had before. This is just managing my ROM and RAM when those are enabled. And I've added a sheet here to start doing some other type of decode logic. And the first piece I put in here is a VIA. So VIA number 1, which is my only VIA at the moment, is this guy. And so I'm going to bring in address 7, 6, and 5, and also this NetIO signal. Well, NetIO is just an inverted MIO. So I have an active, this MIO, hash or MIOB that I have here. That comes from the processor. And that just indicates, am I doing a memory read or an I/O or a memory type of instruction. And if I actually go over, I have the actual formal description pulled up for that. But MIO, it's a bus cycle definition pin that distinguishes between memory cycles and I/O cycles. So in my case here, if I go back to this, If it is a low, I know I'm doing I/O, and I'm going to access this via through I/O, not memory address. So I'm not doing memory mapping or anything like that. This is an I/O address. So if it is low, I'm going to invert it. I have a high signal. So anytime this net I/O is high, I know that that via could be potentially enabled if the rest of the address lines up. So let me get back to this other sheet here. So if I'm going to do I/O and the address, and for now this is too simple. Later I'll have to build this out more, but if I'm doing an I/O, I know I have the first, I think it's 64K of memory. I probably need to go double check. First 64K of I/O addresses. The I/O address space is separate than the actual memory mapped space. But as I get into this, then I'm going to say I'm looking for these three, 001. I'm not checking anything above that for now because I have no other I/O devices, so that's fine. But later I'll have to also check A8 all the way up through the highest bit that's used for I/O addressing. The way I've got it wired right now, at least, is I'm going to use 2, 3, 4, and 5 to know what specific registers. So 1 and 0 I'm not using. That's good on this 32-bit system. So 2, 3, 4, 5 are the addresses that I'm going to use. So I need to make sure that I have the potential that those are all zeros. And that's not necessarily how I have this logic up here. So I might have to change this address a little bit. Okay, so I need to be doing an I/O, and I need to make sure address 6 is a 1. So the way I've done my naming, a B means it's a low. I actually want to make sure that's a high, and I want to make sure that 7 is a B, which means inverted. So if I come through with a 0 and 7, this will bring a 1 into this NAND chip. So A7 is a 0, A6 is a 1, and then I've got my I/O like that. Okay, so now that that is built, I need to actually pull this and program it. And some of these I can actually program on the board, and sometimes I can't. I suppose I could give this a shot and see if it will let me do that real quickly. So I'm going to make sure I get this connected up correctly. So I'm just going to set that here. And you can see it's actually feeding power back into my system, but let me just see if it will let me program it this way or not. And yes, it did. So, okay, so I got that programmed. So now hopefully this PSOC, hopefully I did that on this PSOC here, yes. So this PSOC is now updated to send out this via signal on pin 6 or 06. It looks like I've got it on. And I need to just go verify that on my schematic that I had that coming out 06, which I'm pretty sure I did. 06, yep. So that should hopefully, if I try to write something to that I/O address now, should get that enable signal set correctly. So something else I've got to do here then is also update my assembly code. And previously I've just been running a really simple little test loop, and that was this type of code right here in all the tests I've been doing up to this point. But I've modified this now, so when I turn the system on, I am going to actually set up my registers. I wasn't doing that previously. I'm going to disable interrupts, and then I have a procedure here called via init and via test. It'll never get to this halt because I'm going to put it into an indefinite loop. But via init basically is the code that says, okay, I want to write out to this address, and I've got these addresses here that I can write out to, and I'm going to have to update those to match the actual address I coded in my decode logic. So I might come over here. I've got all these equates set up, but here's all my vias, and I wasn't doing from a 2, I was doing from a 4, and I'm skipping 2 bits on the bottom, so I suppose I'm going to count by 2. Okay, so then if I am within this address space of 40, and that should 40 to 7F, that means A7 should be a 0, A6 is a 1, and I know I'm doing IO, so I'm not in normal memory address, I'm in the IO address space, which is separate. This now gives me my counting. I'm not using A0 or A1, that's why I'm counting by 4s. So this is the first address, second, third, all the way up. I've got my 16 possible addresses. And those 16 possible addresses are going to let me map to these 4 bits down here on this via down here. So 2, 3, 4, and 5. So if I'm doing this off the top of my head correctly and not messing up on the math, those should be the addresses that I'm going to be working with. So then what I'm doing over here in the via init is I'm going to write out to one of the addresses called IER, and that's where I can set up interrupts. And this value is saying disable all these potential interrupts. And I can go look in the data sheet on what they all are, but for now, I'll just say this is going to disable any interrupts on the via. And then I'm going to say set up all the ports. These are the 2, and I can come back over here for DDR A and B, but those are the addresses for those 2, DDR-B, DDR-A. So if I write to that address, whatever I write in the bit pattern as a 1 is an output pin, anything as 0 is an input pin. So this is saying I want all of the pins here to be output, all of these pins to be output. So that's my 16 pins, or 2 different ports are going to be set up as outputs. And then I can write to this port instead of this DDR, and what the port is the actual values. So what values do I want on the pins? And I'm going to start by writing out zeros. So this is going to kind of initialize all the output of the via to 0. So disable interrupts, set all the pins for output, and then set the values of all the pins to 0. That's what this init code is hopefully going to do. And then after I call the init, I call the test routine. And that test routine is going to basically load a 1 into both of the outputs. And so on the appropriate pins for the 2 ports, I should get 7 zeros or 7 offs and then 1 on. And then I'm going to set up a little loop. I'm going to shift that bit left. So instead of the value 1, I'll have a value 2, and then I'll output it, and I'll loop and go to a 4 and 8. Basically increment my way up, turn them all on, turn them all off, and then jump back up to this test. And that's where I'm now stuck in the loop. It'll never get to the return. But it's basically going to set a bit, cycle it all the way through that one 8-bit port, turn them all on, turn it off, and then basically, I probably need to make sure I set it a value in it again, which I jump to via test, and then I get a value of 1 in it again. So yeah, that should be pretty close. So with that code in there, I'll go ahead and build it. It builds fine, and now I can actually program that. And let me get this ROM out of here. I might keep this ROM actually separate and know that I've just got this really basic test on here that I've been using in the past. And let me see if I can grab another chip here. Okay, so this is another flash chip that I will use. And make sure I don't have any bent pins. Okay, so I'm going to use this. I need to program it though, so let me do that. Okay, so just opening up the program software, let me go load the file. So I have this set to the proper type of chip. Okay, so I've loaded up that, and I'm going to say, okay, I'm going to plug this in to my programmer, which is probably a little bit of off screen here, but let me get it in the programmer and do a program. Now the way that I have this is at the very end of this is my jump. At the very front of it is the actual code that I was just programming. And as a reminder, when my system turns on, this PSOC will take the flash and copy it into RAM, and it's going to copy it at an address of E0000. And that's if you were noticing, and maybe some of my initialization code here. There's some stuff I'm doing around that as far as setting up my base pointer, stack pointer, things like that. But let me just get this programmed. Okay, so that is now programmed. So I'm going to get this pulled over and put into the system. And really all I'm doing at this point then again is trying to get these outputs to kind of cycle. And I think what I'm going to do to make it a little bit easier to work with this is put on one of these and connect up a couple of these outputs just to be able to show what is on these ports. So this is a handy just little clip. It clips around these pins and it allows me to quickly put on just standard spacing type of connectors like these DuPont cables. So let me see if I can get this on here in an okay way. Okay, I think that is on there nicely. And so then I'm just going to grab, going back to the schematic for this a second, or the data sheet, either way. So it's basically pin 2 through this pin here, pin 9 is my first port. And so it's showing that the low is on the left. And so if I want that to be this pin here, that's my white. So I'm going to actually go something like this. And then this other one immediately follows. And again, the left would be my low. So I want that to go to the right of my little bar graph here. And so that's my red. That should be something like this. And then I've got 3 pins left over. That would be the CB1, 2, and VDD. Okay, so I'm good there. This will need power. Let's see, power and ground I will need to hook up. Actually, I probably don't even need to hook those up. The power is really more if I'm sending out something. I'm going to be reading in, but I'm going to go ahead and get, I need the ground for sure plugged in. I think that's all I would need here. I don't think I even need the power connected, but I will get it connected, and I'm just going to tap it into this little board here. I've got a handy little power header right there. Power, there's VCC and ground. Got those connected. I put these on standoff so I can just set it on top of this and not worry about shorting anything out. Okay, so that's where I'm at. And then let's see if I kind of just go through a checklist. I updated the PSOC for address decoding. I put in the VIA chip. I am going to try to just show the outputs of the VIA 2 ports to these little LED bar graphs. That should be good there. I updated the code here, and if I don't have any mistakes there, that should be having my processor then send the appropriate control and configuration to that over there. I am still going to be running a slow clock, so this isn't going to run super fast, but then I can pick up the pace of the clock if I do get this working as it is. So that's my next step here then, is to go ahead and get this fired up. I am going to also use this Teensy debugger. Again, I'm at slow clock speed, but I kind of want to see, does it look like it's working through my code as it goes, and use it for debugging and see if I have any other problems going on here. Okay, at this point, I turned on my system. I have it running and just debugging the VIA here, and obviously you don't see any LEDs here, and those aren't lit up yet. And just want to kind of show you what I was finding here real quick. So I have my monitor running here, this little debug viewer that again is going through this this Teensy. I did add to it 2 signals. So I do have the clock. There's an actual separate clock I'm going to generate for the VIA. And I broke it out just so that I can experiment with, do I run it at a faster, like a clock 2, a CLK2 comparable from the board, or just CLK, or if I need to slightly modify the timing of it, like invert it or anything like that, because it really was, maybe best suited for a 6502 or a 65816 system. And on my other system, I know I had done that on my 286, inverted the clock. And a lot of that comes down to timing and things like that. But as I look at this, I can see the A down here as I look at the code that's running. This is looking, I think, pretty good. So like right here, maybe is where it's setting it to zeros. That'd be the 40 and 44. And then if it works and it shifts the bit left, then it should come back and set it to ones. And so I'm just kind of scanning and waiting for the code to come back to that 40 and 44 address. And let's see if I do get to that or not. But while it's doing that, I can also come up here and look at this couple of signals, my clock signal. And I don't know why the clock via is necessarily ticking, but there's my 1 and my 1. Next time it comes through, I should see a 2 basically. So we'll see here if that comes through as a 2. And yeah, there's my 2. So that shows me that the raw code I've got so far seems okay. I'm writing to the correct port address, it looks like. I am getting over here my via enable signal, and I'm seeing that drop low here. But what I don't see, which I would of course need to see if this is going to work, there needs to be a clock signal that goes to the via itself. And so if I go pull that up, that documentation, let's see if I've still got it open here. Let me go over to my via. So that would be this PHI2. And I think I'm reading that pin on my debugger, so I should get something there. And of course, I can come over here to my scope, and that is 1, 2, 3, 4, 5 in up here. So 1, 2, 3, 4. Should be right there. 1, 2, 3, 4, 5. So I should be seeing on my oscilloscope something to show that I am getting my clock there. And right now there's nothing coming through there. And I think it's because back on my clock generator logic over here, I haven't outputted anything for this this via clock. So I'm going to jump over and do that real quick here. And so if I go over to my PSOC, and I'm going to go ahead and maximize this. You know, I'm generating this signal, and it seems like that's coming out okay. But what I'm not getting is something that I've got on my schematic. And let me flip over to that. So if I pull up my schematic here and I look at this via, this clock via here, I can come into my design manager and just kind of trace that back. But if I look for clock via, I can see it coming down here into the via itself, and I can see it coming out up here of PSOC number 1. So this is PSOC number 1, and I should have a pin 1.5 on that PSOC that's generating this this clock for me. But I don't believe I put that in yet. So let's go do that. And if I look at that PSOC, I need to open up actually a different project here. So I do have my shadow RAM, I've got my decode. I should have another one here. So I'm just going to open up this and go do an open. It's not listed there in that most recent, so I'll have to go fetch that real quick. So let me do that. But it would be my PSOC for this PSOC number 1. I'm going to make that the same for now as this clock out. Okay, programming complete. I'm going to go ahead and pull that off. And if that is on there, let me flip back over here and we'll see if we get any clock coming out of that. Okay, so that looks good. I'm going to adjust my scope just to slow it down a bit. And yep, that clock is coming through at a whopping 5 hertz, which is fine. Okay, but now what I'm seeing is, this clock via is matched up with clock up here. I'm also seeing that right now via this is low, and I am hoping that I'll see that pop back up high. Yep, so inactive. I do look over here and my bar graphs are sliding over. So there I've got, you can just kind of see the clock's running so slow that you can see it just kind of crawl its way over. So this is going to go left, that should go left, finish these out, should light up both completely, and then turn them off and start over. And that cycle should just repeat. Okay, so interestingly there, it did not turn on the full, it only turned on half. Oh, I might have just put the wrong value in my code actually, now that I think about it. So let me go back to my assembly for what I'm running on the 386 right now. And in the via test, I'm going to need to set it to FF, and I am only setting it to F. So I need to go to FF when I want them all on. And I always like to put in the number of zeros to represent the size that I'm going. So let me think about this. This would be, yeah, FF and 0, I think, is what I need. So let me build that. Let me then go over to my programmer. And I will open up that latest image, turn off my system, bring this over and quickly program that. Okay, so updated program on here, that should load FF instead of F, which is all I was loading before. And so I just want to let this go and see if it then lights up everything and turns off. And if it does, then that means that this via is working. And then the next thing I might do is try to run this at a faster speed. I'll turn off this specific Windows debugger and give that a shot. Okay, so there I've got my 8th bit. I'm expecting all to light up next. Yep, good, good. Okay, so I'm going to turn this up faster. I'm probably going to go faster than my Windows app is going to keep up because I am logging so much on the Windows app right now. I probably need to work on some optimizations there later, but I'll do that another time. So I'm going to actually just stop the Windows app. It's not, I know it's not going to probably keep up. So, okay, so that is running. So now what I might want to do, this is still running off of a 555, so this is a very slow clock. And if I want to see what clock speed I'm actually running, I guess I can bring my scope back here. And I'm just going to throw this scope on this output. I have a row of headers for clock, an inverted clock, reset, halt, some other things that this card can do. But if I flip over to my oscilloscope output, you know, I can see right now this is running at 254 hertz basically, so pretty slow. This oscillator I have in here is a pretty fast oscillator. I'm going to put a slower oscillator in there. And I can kind of tell by looking at the PSOCs, when this one was solid, it was still doing this initialization. And then as soon as they started both flashing, it's going through my code. Okay, that's running. Now once it's running, seems like I can turn the clock up fine. But there's something during that very first turn on that I'm going to have to figure out. And it could be something to do with the way I'm handing off control from my shadow here. So this again is copying RAM or ROM into RAM. And maybe there's a slight timing issue or something I need to do there before I let the system start running, or there's something else going on that I need to now probe into. What I want to be able to do next, though, is go to a faster clock. And like right now, if I flipped this to the faster clock, well, interestingly, that does almost look like it's running. So I might just go see if I am getting something out of that. So if I grab, I need to just carefully grab one of these pins and see. Far right one would be the slowest, or sorry, far left. I gotta be careful here. I don't want to do this without connecting to any other pins accidentally. Okay, I'm looking at this and I am getting a kilohertz out of this far left LED. So it is running the code right now. So something with the initial startup, if I have it running too fast, it looks like it has some type of an issue. So I'll have to figure out what's going on there. Okay, so right now what I'm doing is I'm just starting up with the 555 clock. I cut it in half and half and half, so that's 120/60. So it's only running at like 30 hertz right now. But I just want to see if I can get this going to where it's initializing and then flip it to the oscillator, and that'd be 500, 250, 125. That'd be like a 60 kilohertz if I'm able to switch this over. And yeah, that works fine at that point. So there's just some initialization. Oh, it's even letting me move the clock without causing problems. So, okay, so that is working okay. So I guess here I slowed down the clock. So I've got the 1 megahertz cut in half a whole bunch of times. So I'm running at a pretty slow speed. And if I want to just quickly validate what that speed is, you know, it looks like I'm running about 2 kilohertz, not quite 2 kilohertz at this speed. But it runs all the way up to, you know, the full speed up here and actually the double of that. So running at half a megahertz without problem. And any of these other full speeds, once it gets going, it's fine running at. So I just think it's something in my PSOC timing wise. I've just got to get that initialization worked out. But good enough for now. That's where I'm stopping. I'm happy with the progress. So I have a working VIA. I'm testing the output. I now know I can use that VIA to do other things. And in this case, that's going to be really SPI to my Nano, and try to get all that working. In the next video, I'll probably come back and do some troubleshooting, figure out why, you know, is it this PSOC is not liking the initial fast clock when I turn on the system? And if that's the case, what can I do to work around that? And it could be, again, the way that I'm doing my shadowing, that there's just when I let the system actually go, when I'm done with the shadowing, maybe I need to do a little cleanup work on that.